All right, hello everyone. Welcome back to CPE 517-WS Digital and Computer System Architecture. This is part 5 of lecture 10. We talk about cache behavior summary of snooping data structure. Snooping protocol, sorry. So I already give you guys some hints about how these things works, right? So one is active participant, one is passive participant. Can you guys sort of use 20 minutes or so to think about how these kind of things would happen? Like you have a read heat from a processor. How are you gonna do? What kind of cache action would it be? And can you explain the status of this? For instance, you have a read heat here. You have a read heat here, right? So it's the cache is in shared or modified. What action did you do? You actually don't do nothing, right? Because it's already under you, and it's a read heat. So can you also work on this? Like read means from processor, the state is invalid. Read means processor, it's shared, etc., etc. Okay, use 20 minutes to think about it. Pause the video. Okay, come back to the talk. So I'm trying to explain to you all of those cases because this is going to be used next slide as well. So please be focused. It's very important. Okay. So when it's a read heat, it means the data is there, is in the processor. Okay, it's a read heat. It's good. It's a normal heat. Okay. Read means on invalid. Invalid, it means the data you requested is invalid. It's a typical miss. So, or this block is not caching the data of your interest. But either way, you put a read miss on the bus and then you read the data, right? And then if you have a shared status, you still put a read miss. What does it mean? It means you have address conflict. Right? So say you probably have the data here. So you have this value here, but actually you're requesting this one. So in this case, you're gonna have to replace the block. So we have a modified of a read miss is the same, right? So basically you have this data here is modified. It means you just modify the data. So what you have to do is have to write this value back to memory and also load the requested data. Okay, talking about this one. And then you have a modified and you have the right heat. It means exactly the data you requested want to modify is there. So it's a normal heat of write. If you have a shared status and then you have a write heat, that means you just read the data just now and then right now you want to modify it. So what you're going to have to do is you have to place the invalidate on the bus, and then these operations often upgrade the ownership of the misses because they do not fetch the data but only change the status of the data and also invalidate the other cache blocks. If you have invalid, you have a write miss, you basically place a write miss on the bus, right? So this can trigger other processes to do something. And then if you have if it's a shared status and then you have a write miss, it means what? It means the data you are trying to write to is here, but actually you have cached this one. Okay, it's an address conflict basically. You place a write miss on the bus. Sorry, there's a typo here. So if you have a status of modified and then you have a write miss, it's the same as the upper one, right? You have a address conflict, you basically, but then you also have the data as valid. So what you have to do is you have to write the data back, then place write miss on the bus. Okay, so this is where till here we discussed the cases that you actively sending data on the bus. Assuming you are studying here, where processor 1 is sending information to you, right? So you have a address as a shared, and then you have a read miss. So what do is you do nothing, because it has nothing to do with you. You have this shared, it's staying there, nothing changed, okay? Allow the shared cache or memory to serve the read miss. You can either provide the data to this processor or just let the processor go to the memory. Either way is fine. And then another case is you have modified and you saw there's a read miss on your specific data. What you have to do is, it means other data, other processor, the processor 1 is actually requesting some data of your modified case. What you have to do is you have to place the cache block on bus. You also have to write back this modified data to memory, and then you change the status from modified to shared. For if you are in shared case, but you see invalidated, what you have to do is you just change your status as invalidated, right? And then if you have a shared case and then you have a write miss, what you do is you also invalidate your cache block, right? If you have a modified case, you have a write miss, you do is you write that back, write that cache block back, and then you make your status as invalid in your local cache. So the action is, these are all for coherence situation, right? Because whatever you have is on your own case, but it's not there yet. So for these kind of situations, this tells you how different cases will be covered in these two processor coherence protocols. So it's actually not very easy, right? So it's complicated. There's so many cases. So what we're gonna do is in next lecture, we will also go deep on this, okay?